Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining this Neo4j Live, Cognitive Sciences and Dynamic GraphRAG. And I'm very happy to have my guest this evening for me, Vasilije Markovic. Hi, how is it going? How are you doing this day?
Hey, thanks a lot. Actually, pretty good. I just talked to Tomasz from Neo4j
Oh,
just
nice.
before the call, so I think today is the Neo4j day for me, and I'm pretty happy to be here.
Yeah, great. It worked out. We had planned this actually session. I think in August, a couple of months ago, but there was sickness involved and you couldn't come, so obviously we had to move the event to today. So I'm very happy that we can still we're able to squeeze it in before the end of the year. We have a couple of weeks left before it all wraps up. So I'm happy that we can quite not really repeat, but we can redo the event that we were supposed to happen in August. So, and then you had a couple of great news as well in between. So I think maybe even better that we had to push it back a little bit, to get the
Yeah,
picture a little rounded up.
sure. Thanks for postponing. I got really sick. I was trying to take a holiday after a long fundraising process, which, yeah, as the news are, we managed to raise 1.5 in summer,
Nice.
and yeah, I got sick after all of that, and I was supposed to do this with you. I think
Yeah.
it just yeah, came out of me, the tiredness and everything. So although I was in a really beautiful place in Croatia, my eyes were like all messed up. I couldn't see much. So now I'm back. I can see, and I'm happy to participate.
No, that's great. That's great. And yeah, congratulations again to the round. I saw your announcement on LinkedIn. When was that? A week ago, actually.
Yeah.
When you posted it with a couple of investors into your company. And I guess we get there when we talk a little bit more about the topic today. But yeah, it's great to have you today.
Great to be here. So yeah, I'm happy to share more about us, about the approach we are taking. I've seen a lot of your, let's say, talks in the past, and I think they all kind of have the same type of a direction, and then some are more technical, some less. So I'll try to kind of keep this on higher enough level and kind of explain what we do, and but still give some maybe examples and show to people how they can find the resources.
Absolutely. Sounds good. Hello to everybody watching live and chat. I see Andreas, I see Alejandro, I see Walter here, Guzius from the US, giving, I think I would say quite indirectly giving a Thanksgiving note. So happy Thanksgiving to everybody watching in the US. He's thankful for all the great graph database knowledge Neo4j gives away for free. So yeah, we're happy to have you today, joining this session before the big long weekend, I guess, in the States. Yeah, before we dive into cognitive sciences and dynamic GraphRAG and Cogni a little bit, I guess. Vasilije, would you mind giving a few sentences about who you are, what you do, and maybe a little bit about as well how you came to the world of graphs? How did you discover graphs? How did you make that as I would say a pillar even of your job life nowadays? So it's always interesting to hear a little bit about backstory.
Sure. So I'm Vasily, 34, originally from Montenegro. I've been in Berlin now for around 10 years, working and living here. I graduated with a degree in business around 2013, worked in a crypto exchange, helped scale it from 0 to 10,000 users, and learned how to code and build, let's say, flows and customer funnels. I realized I like data more than I like crypto at the time. As everyone has the preference. I liked crypto in the beginning, but then I got sour on it a bit. And as I was moving through my career, I became a data analyst and data engineer, data product manager, mostly managing big data systems. So I worked for a couple of companies here in Berlin, Zalando, Taxfix, Omio, and I've spent the time pretty much, doing data modeling, right? So in the end, it's the problem with relational databases. Although the structure is relatively clear, everyone has their own interpretation of a session and what they're doing. So as I finished that, I became a consultant, worked for a couple of other companies that had even bigger issues with these types of problems. Then I got bored from moving data from place A to B. I went back to uni, started studying cognitive sciences and clinical psychology actually. And as I was doing that, LLMs showed up.
Hmm.
The LLM showed up in full force. Of course, they were there before. And I was working on some interesting projects for some clients, and then I decided to just start working on something on my own. So the road was rocky and interesting. We needed to build a couple of B2C apps. I realized I know nothing about building B2C apps, and then gave up on that one. But what I noticed is that when I was using tools like LangChain, and when I was trying to resolve things there and have like some stable contextual memory, I wasn't really getting far. And I realized then as I was doing like these cognitive science courses and learning about human memory and like let's say dynamic entities and objects that we could how we use memory to represent things. I figured, okay, maybe we could like kind of model this in a different way, have like this, let's say, more probabilistic entities that can be evolution of this, relational model. And I thought, what could I use to do that? And then Neo4j popped up. So I just figured, like, okay, I didn't know much about graph databases at that point. I figured, let me do this because it's the best way to represent and evolve the entities as they come along. So we built the first prototype, launched it with a WhatsApp chatbot in production with around 20,000 users. And then we realized, okay, all of this is wrong. We couldn't really generalize things. We had like a lot of assumptions, and then we went on this road to build Cogni as a Python library, and that's where we are at now, kind of evolving step by step with the approach.
Yeah, cool. That's very interesting. Love to hear your thoughts on entity recognition with graph database at some point maybe, but let's not deviate too much from the topic of today. But it was just it's a top of mind thing that we're currently looking at for our Going Meta series that runs in parallel. So would be interesting to hear your thoughts maybe if you've got some time at the end. But yeah, that's a cool story for sure. Thank you for sharing that. So we see you starting with crypto, then going into data modeling, then now founding your own company. And um, I guess graph has been kind of part all the way. I mean, even with crypto, it's not really core part, but you kind of like had an inkling, I would say, to the technology still without maybe even realizing. So that's always the funny thing with graph technology, or with for us at least. It's like how many things actually are graph problems, or could be solved with graphs, or are built on graph technology even without you realizing it. You try to manage something and you do it with traditional kind of like technologies, and then you realize, oh, actually I could have done this with a graph database or with a graph technology, and this would have saved me so much work. That comes sometimes later. Yeah.
So it's about these concepts that you learn at some point, and then you start applying and like externalizing. But until you know them, you're like kind of stuck in the old way of thinking. And I
Yeah.
think I'm super happy that I started working with graphs. Maybe a bit late, but still sooner than later.
Yeah. Yeah. Cool. No, that's great. Let's continue and talk about cognitive sciences and dynamic GraphRAG. So I don't know if you have any slides, or if you wanna do a demo, or if this is more if we can talk about it some more. But I just wanted to reach out to the audience. If you watch this live and if you have any questions, any comments, and please feel free to put them in chat, and I can read them out. In either in a break session, or towards the end, and then we can cover a couple of the additional questions that come up.
Sure. So how I was thinking of doing this, I'll kind of explain things a bit verbally. I'll show a Python notebook and then kind of go back through the things we've done and kind of again explain. We have some semi slides in that notebook that I think could
Yeah,
be interesting to
that's
stop
good.
at.
That's great.
And then we can actually also talk and check the questions. So cognitive sciences, right? And what are we actually trying to do, and how does this let's say approach evolved? And I'll tell you the story of what we were inspired with, what models we used, and what we were thinking, and where we are going with it now. And I think this story from the beginning to this day, I think it can actually, we can introduce a few concepts there. So
Hmm.
when I started actually with this problem of modeling these entities, let's say in the graph store in September last year, and how can I actually create a context for LLM that can be useful and that shows the relationships between entities and make the LLM get to a better decision to increase the accuracy, reduce the cost by already pre-processing that. I was basing a lot of my thinking on these models from cognitive sciences, such as Atkinson-Shiffrin and all these, let's say, computing paradigm that was in use back in the 60s, 70s in psychology. So what's Atkinson-Shiffrin model and how do these things look like? So when we talk about human memory, and it's important to distinguish between the storage and then the memory processes, right? So the memory storage or the memory domains is something that we use every day to store certain type of information. So when we hear some word or see something, we usually get 100% of that information stored in our system, but it's for a very short period of time because we can't just keep all the things, the audio, olfactory, and other signals that we notice. We just kind of have 100% sensory memory that we get, but unless it's really activating other part of our system, we just let go of that. That's one piece of the memory. Second piece is the short-term memory. You played with that or heard about that. It's like how many words can you remember or numbers in a sequence, and how many can you keep in your short-term memory when you're trying to copy from one paper to another. Mm-hmm. The short-term memory has a bit longer span, but it usually can't also translate into anything you're going to remember after a couple of years unless it's really eventful, and it gets then stored in the long-term memory. This is what Atkinson-Shiffrin pretty much said. So you have the sensory memory, you have the short-term memory, you have the long-term memory. Long-term memory is where you actually remember things and you know what's happening and you can recollect the childhood events. So this is called the episodic memory. So episode of your life. When you got married, you got a kid, you went to the first day of school, and then we have this what's called semantic memory. Semantic memory is where we are actually remembering some facts or information about facts. So this is a whiteboard behind me, the concept of the whiteboard, the concept of the wall, all of these are pretty much stored there. So when I was playing with the LLMs in the first moment, I was like, okay, I need to store the data somehow and pass it to the vector stores. But because the vector stores only have the embeddings, they don't have any type of conceptual mapping where would these embeddings belong. I'm just searching, and getting the data back. So what I was thinking, okay, how about I hard code these models? I put I have a short-term memory, I have long-term memory, I have episodic, semantic. Then there was a Princeton paper about koala that just came out at that point when I was exactly doing that. I think I posted 2 weeks before they published the paper. Right? The first time I was faster than Princeton and probably the last time. And I was like, okay, I had the same idea. They just did it much better, of course. And then when I was implementing this, I was implementing that in Neo4j. I was creating certain nodes that would represent the memories, and then I was attaching the data and decomposition I was doing with the LLM structured outputs to each of these domains. So what that led to is, as you can imagine, I had these super nodes, this problem of super nodes that had too much data associated with them, and then I had a lot of let's say these memory components that over time grew, and I couldn't really do a good retrieval. So as we implemented that for these WhatsApp users in a chatbot, and they started storing their memories and searching for them, we did marginally improve their, let's say, reliability of vector stores by giving, let's say, a way to navigate through certain types of memory domains, but these memory domains were still too static. So the next thought I had was okay, because I know that in the cognitive sciences, we have different, let's say, processes, memory processes that we use every day. So we have forgetting, which would be decreasing over the amount of time the importance of a certain event until it disappears from the memory. And these types of things could be relatively easily coded into the system. So the next attempt was hey, how could I maybe alongside each of these information points I was loading to each of the memory domains, how could I actually add things about recency, frequency of use of this domain? So in the psycholinguistics, in the cognitive lexicon, which represents all the knowledge about all the words we use, there is this hypothesis that all the words that are on top are there because they are frequently used. So frequently, I'll use much more than oxymoron, or some.
Okay, I see. Yeah.
This was kind of the approach, let's kind of code that into the system and kind of re-update the system. So this is where starting to get the dynamic approach, right? We are kind of adding these weights and kind of using these weights and making these relationships, not like Vasilije owns I don't know, this, or like this is happening there, which is what most of these LLM simple projects do, but having these numerical relationships that are kind of increasing in size, decreasing in size, and that we can quantify.
Yeah.
It enables a lot of fun math on top of that, right?
Yeah,
So
you add like you store the facts, but you also give them like a soft additional information to it that is maybe this is importance. I think something like that, so that you can add it into to afterwards and say, okay, this was a really important event, so I guess it's 10 or something, or this was not so important, so maybe it's a 1 and then it gets forgotten, or maybe it gets removed even, I don't know. But okay, that's cool. That's an interesting idea.
yeah. I mean, like it's known in psychology, and what I thought, like, okay, this is not known in computer science in this
No.
way. We just focused on these transformers and these
The
black
internet
box.
never forgets.
So I think, like, yeah, exactly. And yeah, in the end, what I was thinking about is like, how can I actually make this scale, right? Because what I saw as a biggest issue with these types of processes is we would need to process, let's say, millions of nodes. We would need to update, subgraphs of information, deal with like very complex edge cases that require, let's say, some stability that most of these approaches that I was doing at the time I couldn't really reach, right? And that kind of pushed me and my co-founder Boris at the time to think about how can we actually make this solution a bit more horizontal and a bit more, let's say, mature in terms of the technology stack, so we can kind of come closer to production processes and doing this at scale. We were pretty aware that like cost of OpenAI was kind of forbidding at that point, but we assumed it's going to go down. Like the price of the tokens was going to reduce, and we're going to kind of move with that. So we released a Python library. We created the first Cognify pipeline that did pretty much this, and then and used Neo4j as the store, used OpenAI's LLMs, used structured outputs, created these graphs and these artificial domains of memory, and we, even with these updates, with these, let's say, numerical properties we would add to the nodes and the edges and try to kind of quantify them, we were still running into a lot of issues, right? Because we simply needed like to be 2 levels above in terms of the performance and operation to actually, be able to process 1 terabyte of data. Because with 150 megabytes, you can do anything, but like with compute that require, for big companies, it becomes already difficult. And I think one of the reasons why Neo4j is one of the rare companies that managed to solve the graph database problem is because it works at scale, and even Neo4j has issues at certain point, right? So you need to be careful on how you deal with that. That led us to kind of think about the product a bit more. And we thought that we should simplify the whole interface, because this now was getting a bit too complex, to a set of abstract components. So one of the components, and maybe I will go through the example now, because it's maybe a good time to start introducing these elements. So you can run this yourself. We have also here a Colab notebook. I'm not going to run it now, but I'll kind of show you what we had in mind.
And you will share the link. Maybe you can share the link with me afterwards, and I can put it in the video description.
Yeah. Will do. So if you just search for Cogni on GitHub, you should find us. So effectively, we are here introducing a couple of concepts, which I now mostly talked about, and I think it's already clear. But this demo is effectively just talking about some CVs and some job descriptions. And we are trying to extract entities and match these CVs to this job description. So in this context, you can see the strings we just used to kind of illustrate the point. And how we try to resolve that is that we effectively have this concept of Cogni.add. So Cogni, as a Python library, has a relatively simple interface because we didn't want to overcomplicate things. Add command takes any type of data, so PDFs, images, audio, and stores that inside of the system for further processing. So we saw that a lot of issues that happen with the systems, like GraphRAG systems, were not enough data engineering, right? So we use this library called DLT behind that creates, does the JSON normalization, standardization, creates the merge IDs. So we have all of that data that we need to actually be able to replicate and rerun the pipeline when we need to, because this is one of these guarantees that we can run something in production. And once we do this first step, we can do it here as adding a list of all of these job positions, but we can also add paths to any file in the system or S3 buckets or whatever is needed. And then this data is going to be processed, normalized, and we can actually create the graph out of it. So what we decided to do in terms of the architecture and how to approach the system was to create a set of tasks that are tying into pipelines. So I worked a lot with Airflow in the past, and in this data engineering DAG space, so these graphs, the centralized theory graphs, we saw that this type of a use case is relatively flexible and relatively useful. Haystack is doing something like this, similar. But what we try to do with these tasks is we give them a state, and then we are allowing every task to inherit from another task. So let's say this classify documents task is going to pass the information about the classification to the permission checking, which is going to pass that to the chunks. So only the chunks with the permission are going to be extracted. And we can pretty much structure and organize the data in this way. So this is nothing too new. But for us, this was one of the key things to unlock further experimentation with this cognitive approach, because we could then finally play around with different approaches without having a hard-coded static system that probably won't work all in 3 months, because we just assume something that might not be true. So Cogni as such is now effectively a pipeline that is combining a set of tasks that are running in parallel, in batch, or sequentially, depending on how you set it, or async. And then what we did also is we recognized that everyone has their own use case. So we created a set of infrastructure adapters that you can just connect to at any given point. So you can use multiple databases, relational ones, vector databases,
Cool. Yeah.
LensDB, pgvector, Pinecone, Quadrant. We have here also Falcor DB adapter. We have Neo4j drivers, NetworkX. So you can run this locally, but you can then also have it running in production with one of these bigger players, and it should be relatively straightforward. We also support multiple LLMs. So once we did this, and once we kind of built this type of a system, what happened was that we figured that, well, this is not really working that well, not in terms of like technology. That part we felt more confident about than just the graph generation. Mm-hmm. But in this case, we had, like, let's say we were trying to do retrieval. In this context, we are, trying to, we can do the search on the vector engines. We can do search for maybe summaries, and then just search for the nodes in the graph. But all of this is still a bit too granular for an average user, right? And it's going to take a lot of engineering to get to the good results, and we spend a lot of time ourselves doing this. So we were thinking, like, okay, this is probably not going to just work like this forever out of the box. So we needed to add, again, another layer of automation. So when we talked about and I'll switch back to the screen. When we talked about the approach of kind of storing the data in the metadata, that is effectively like, so these, let's say, numerical classifiers or metrics, we thought about actually a different approach. Why not actually extract all of the relevant things we can optimize for in the pipeline outside of the pipeline itself? So I'm talking about chunking, I'm talking about which LLM we are using, which vector store, which data model we are generating in the graph, and how. And how about we actually create a system that kind of automatically evolves this? So the approach there was, and this is something we'll release relatively soon, is to have this pipeline be an evolutionary pipeline, as we call it. So a dynamic pipeline that just fixes itself based on a test set it is evaluated on. So let's say Are you following me, or like should I maybe clarify a bit?
No, yeah, yeah. Talk a little bit more about that. It sounds interesting, but yeah, that is an interesting approach here. Dynamic, updating, dynamic, almost like a, um, you know, living knowledge graph or living knowledge base, and that is constantly changing, a little bit evolving. Almost, yeah. We always talk about a graph is similar to the brain because the neurons and the synapses are like nodes and edges, but we didn't think it as as literally as you are thinking. So it's an interesting approach. Yeah,
Yeah, I mean, the nature of systems is to evolve, right?
yeah,
And I think the approach here was like the initial understanding is like that. You come in a workplace in 2 years, it's a different workplace.
mhm.
Like 30% of people left, 30% of people joined.
Yeah.
Different. Like you don't know. So I think like every type of a system is an evolving system. You can try to kind of keep a system from changing, but then things tend to kind of end up in Fortran in a bank for 40 years. But do we want to be that?
Yeah.
So the way we're thinking about this is like, hey, we have static data warehouses. There is 140,000 companies using data warehouses. I did some analysis with like in Google Cloud and Redshift and whatnot. How about we have like a probabilistic data warehouse? How we have entities that are evolving in a data warehouse where schemas and relationships continue changing based on how good of the answer they are providing to the problem, right? And in this case, this is the first step for us is like to create these data pipelines in such a way where I add like a test set that actually a train set in the traditional ML approach with some question answer pairs. I pull that through the pipeline, evaluate it at the end, see what kind of a graph did I get, what kind of a combination of searches did I get, and how they're evaluated. Then I say, oh, okay, this is not good enough. Let's loop it back, right?
Mhm.
And then I just loop it back, or I can launch it parallelly. I can do many things with that. I can do all these like types of computer science, searches, optimize and start from the middle, start from the ends, whatever. Like that's all these interview questions from Facebook. I never got that far, so not gonna try now to pretend I know too much about it. But like, let's say that we can apply different methods, and with these methods what we would get to is effectively a self-improving pipeline. The self-improving pipeline is then going to stop at a certain stage when it passes the test. Now, maybe it's over-optimized.
Mhm.
Maybe we just overtrain or overfit that on the train set. So we then pass it through the test set. If it passes the test set, then we know that this data representation that we made, this, let's say, dynamically improving data representation that's where we are adding new things, interpreting them in different way, deleting things that don't
Mhm.
matter, is one that answers the questions from our stakeholders. And this is the way we could avoid like tweaking the chunk size, tweaking the all these like factors in the GraphRAG pipelines that are really time consuming and ineffective. And then in the end, we could also create another pipeline which is feeding the feedback of the stakeholders to kind
Yeah.
of create a layer above that is kind of again influencing how we are communicating results. Maybe you can do an interview with the analysts that are using the outputs of this data. Maybe you can create a chatbot that's just feeding the data back.
Mhm.
But you're pretty much, again, you have a feedback loop. And with this feedback loop, you have an improvement, you have a measurable improvement, and then with relatively good evals, you have, let's say, a way to move forward. So this is something that yeah, for us is I think the first step towards this. If you think about a snapshot of human memory, which a current, let's say, Neo4j graph would be, to
Mhm.
move it towards this slowly moving dynamic memory, and then we are assuming like, okay, the cost of tokens are going to be, I don't know, a few cents per million tokens in a year, and they're going to be doing that in like, you could produce millions of outputs in like a couple of seconds. So we're probably going to have ever increasing speed of these things, and we're going
Yeah.
to move like we did with like data engineering from batch to streaming over time, and things are
Yeah.
going to get done magically. But yeah, for us right now, like even if we can prove this as a proof of concept, is already like a step forward, I think.
Hmm. Yeah, that's very cool. And you you always have complete view on each of these processes. So that helps a lot, I guess, to understand a little bit better what is actually happening, because you are updating the data, you are reconfiguring the data, and then you're outputting the data, and then the data becomes your living and breathing almost knowledge graph or knowledge base, and then you put that data into your chatbot or other generative AI driven systems. But you always know, okay, this has happened because of this, and this change has happened because of this, and this is the evolvement. So you can always follow that. You don't have a viewpoint into something which you can say, yeah, something happened, but I don't know exactly what happened, and I cannot explain to you why it happened this way. But I just know that this is what I get here as a result, and that's sometimes going to be hard, especially for more complex data, I guess, and more data where it really is really important that it is correct and true.
True,
You Yeah.
true. I think that you're opening up a good question. What is the data? It's harder for the data that needs to be true. I think we changed the paradigm, right? So we moved from like relational data that I could map one to one, and I know always like what's true or false, to
Yeah.
probabilistic systems that spin out some tokens, and that is, I think, going to lead us to, we can probably only give a certain high percent chance of accuracy, but we can never be 100% accurate. So most of our job now becomes not only building these things, because it's relatively simple to chain them together, right? And there is all these chain tools out there.
Yeah.
Uh, I think it's about like making sure that they work, because when you hit
Yeah.
70% and you need to move to 90, and then have a way to actually avoid, your chatbot giving free coupons to customers, your own reports. This is the difficulty.
Yeah. Yeah, that's good. I was wondering, because I had a session recently on agentic AI, and I was wondering if the approach you just outlined, and with this more agentic driven systems, I think this is the current trend. I see a lot of people talking about this, but your approach is to some extent, it sounded to me, but correct me if I'm wrong, sounded as like a similar idea, but you giving it a more, you keep the process with you, so you don't give it away as much. Because with agentic AI, you just say, okay, I have this idea of a process, this needs to be done, so AI do this. Then I have another idea of a process, AI do this, and then AI do this, and then I combine them in the end, and then I have something where I have processes in between which I have no control over, almost. Something happens, and then something gets back to me. And your
Yeah,
approach seemed to be a little bit more, you are trying to structure it and trying to give it a more of a yeah, more of a controllable feature set.
exactly. And I think we're trying to reduce the complexity by reducing the number of variables that could change, and then keeping that much more in line with the data engineering and data processing practices, versus like, hey, can this agent do something broadly undefined and solve it for me without specifying the exact needs that I have? So I think for us, the major part of the work is on defining the evaluations, and on making sure that the system works at the beginning and the end as it's expected, where these other parts can be automated. Whereas I think with these agents, a lot of it is defining the middle, right? This set of
Hmm.
steps that
Yeah.
you expect the agent to do one by one, one by one.
Yeah.
For us, that's not as important as like having a more reliable data store that the agents can write to, read from, versus just having some data store that won't work even in these use cases. So yeah, I would say we are more about like the accuracy and scalability of this data, to what degree we can guarantee for, versus just having a complex vertical use case that with the advancement of these systems might be outplaced or replaced in a couple of in a year or two, or whatever is happening.
No. Cool. There's a question from Jan. So maybe I read that out. Do you have any slides or diagrams describing which data you actually store in your system, or which data you are using with this dynamic GraphRAG approach? How do you come from, let's say, jobs and CVs, or from something else to the knowledge graph? I don't know if you can show a bit of that or explain.
Yeah, sure. Let me just check. I think I have another example somewhere, or just a second. So effectively, I think the example how we actually do it is the structured outputs. So what we do, we would give it, we use pedantic models everywhere. So you probably all have seen this. We just provide the pedantic model via instructor to OpenAI's API with the data, and then we pretty much try to fit that in. So let me see where the models are. But I think, yeah, this you can pretty much, I'll share the link here. So I would say that this is the, yeah, I'm sharing this in the chat.
Oh, perfect. Yeah.
Yeah, so I think for you, Jan, yeah, it's like it's effectively just using the instructor that you see here under the hood with some pedantic class. In this,
Do you share your screen, by the way? Because
yeah, I'll do that.
Here we go.
So yeah, this is a underlying thing. So I don't go through our code because there is a lot of stuff there.
Oh, yeah.
Yeah, effectively, let's say you define some class called user, then you pass some data to it, and then effectively you're going to get generated, you're going to get the pedantic class back with the data filled in based on the data you fed. So if we, let's say, feed all these CVs, we defined the graph object, which has some nodes and edges, and that gets filled in. So this is not something that we want to continue doing in this way. So we have a new project that we're working on now that's called GraphRAG generation. So let me see. I think I would, yeah, I'll stop sharing the screen. I'll try to find it somewhere and show it, where we are kind of combining more deterministic methods and LLM methods on top. So for example, in this case, what we're trying to do is help a coding copilot build a graph representation of a GitHub repository, and then enrich that, and then help actually answer any questions on that GitHub repository to this coding copilot as person is interacting with it. The current way they do it is like they just create embeddings, store something in the vector store, and then they hope for the best. With this, we're kind of, well, it is true.
It's true.
With this, we are trying to pretty much narrow it down a bit and give them a space for search that could make sense, and then again evaluate that, test that, and adapt that a bit more. So so the graph generation in itself is, let's say, a relatively complex problem, and for different use cases, we are thinking about different potential approaches that could work and that could actually make sense. I think for us right now, this is a place where we are kind of experimenting the most, and where we are really trying to do as much as we can on the topic of let's say on the graph generation and graph retrieval. So I think I found it. So I'll share a bit more on this.
Mm-hmm.
So this is code graph pipeline, it's called, and then in this case, we have pretty similar set of tasks to what you saw before, but then here, for example, we have this class called source code class that can effectively represent the information about the graph that we can extract from the LLM, but also generate with more deterministic methods that is going to contain nodes that can be a class instance, node function call. So this is all the things you're going to find in a typical repo. And then we can do this on different levels. So as you see here, we have expressions, function calls, we have class instances, operators, variables, so all of the parts of the actual code base, and then we also have the files and then relationships with these files between themselves. So this gets pretty complex. The trade-off here is where do you actually make how granular do you want to go? Do you want to see where each variable is connecting between itself, or do you want to kind of stay on the file level? So the answer is be somewhere in the middle, but that piece, we don't want to fine-tune, we want to automate the tuning of that, and then we'll see how that kind of works with these eval sets and the things we are building right now.
So is this almost like ontology creation where you define a bit of a structure first, and then you said, okay, this is my structure, this is what I want to see, and then you populate the fields accordingly.
Yeah, pretty much. We're thinking of ourselves as, DBT of the future.
Hmm.
So you want to create like data models, but you want them to be ontologies. You want them to change, evolve, and then you want the system to fill in the blank somewhere. But you also want human in the loop on other parts.
Yeah, that's cool. Um, where would you say is a what's a great example or a great application, I would say, even where your system or the concept of Cogni, where that is particularly successful or particularly good place to try or to use in a as a use case or as an application setup.
So I'll preface this with an explanation of how I'm seeing the space now. So who are the people using these types
Hmm.
of tools, right? I think back like 7, 8 years ago, data science was an esteemed, prestigious thing. Everyone was trying to be a data scientist.
Yeah.
Then not many people were, and not even less people had like the required mathematical background. I'm not a mathematician, but like I know when I see one, like who's a good one, who's a bad one. Like I do have some training in these things, but I would not call myself one. And then because it was so difficult to productionize these data science systems, it was relatively a niche, and it was these types of systems were used to improve, let's say, a certain part of a company and increase revenue from 3 to 5% if they are doing well, or decrease it by 5% if not,
Yeah.
depending. But you wouldn't see like data science become a mainstream thing. I feel with the LLMs that changed because now everyone's a data scientist. You have an API, and you can just do magic that you couldn't do like 7, 8 years ago. You would require like three, lead engineers and like data engineers, two data
Yeah.
scientists, one analyst. So it would be much more computationally resource intensive. So with this, let's say, openness now of the system, we have a lot of people more moving into the LLMs, into graphs, into everything that's related, and
Hmm.
they need a bit more hand holding than people in the past did, because they had to kind of go through these, let's say, complex problems and scaling issues themselves. And now people still just simply assume things will work with the LLMs because you're going to throw something at the API, work, do magic, but then the rest of the system is probably going to collapse if you don't really maintain it or build it properly. So what we are trying here to do, and how we are looking at this, is we are looking at people who are moving into the space. We're trying to give them tooling to find the use cases we can't even imagine, right? So I
Yeah.
know a guy, he built a teleprompter tool. So when you're doing an interview, you would
Ah.
have a teleprompter running, and
Yeah.
then it's going to analyze what both people are saying. So I'm not using that.
That would be good.
Like I would be listening to you and
Yeah.
responding to Jan's or other guys' questions, and then it would just suggest responses, so I could just read. I would be like, American president, or I could be like, I don't know. I
Yeah.
wouldn't have to think for myself. And not saying that they don't, but I'm just saying it might be easier.
Hmm.
And effectively, this teleprompter tool is now was making 1.5 million in revenue in May this year.
Oh wow.
Two
Yeah.
guys,
It's great.
just building a teleprompter tool, and like
Yeah.
they did a good job marketing it. But I think like AI is opening things I couldn't even imagine before. If you
Hmm.
could tell me that
Definitely.
AI is going to analyze our discussion and give me a prompter to have better responses, I would be not expecting that.
Hmm. Totally.
So, yeah. So to answer the question now a bit more granularly, we're seeing interest from different types of verticals, construction, agriculture, a lot of people who have a lot of data and are trying to kind of merge this data and analyze it and create and have better insights into the things they don't have time to read or understand.
Hmm.
And
Yeah.
with the LLMs, it's either unstructured data or it's a combination of structured and unstructured data. So
Yeah.
text to SQL, then pretty much code generation is one big use case we've seen, and we've seen a couple of others. So I think, in practice, we're seeing, let's say, two groups. One is the people moving into this space, so we want to give them an easy tool to use, and that's where I
Yeah.
try to simplify it and kind of abstract out the data engineering behind, because that's the difficult part. And the second group is like these companies that have a lot of data, a lot of PDFs or unstructured or semi-structured data. They just want to put somewhere and make it useful. So kind of unlock this data access.
Oh yeah, yeah, yeah.
Oh, I've been talking a lot.
Yeah, no, that's great. That was very informative. Yeah, and I think that's a huge space. I mean, we talked a lot about unstructured data these past months. I would say everybody was talking about, oh yeah, I have my data set of huge PDFs or emails or some other stuff I cannot really access in my data set. But I think we tend to forget that there's more probably on data that is actually structured, but is still sitting somewhere in a system and it's isn't being used. And if you then enable people to actually combine the huge amount of unstructured data, which can be messy, and the huge amount of structured data, which also can be messy in truth. So, and if you combine them together and then make something that is actually accessible and that is actually giving something to the user or to the developer that can then be worked with in, that the chatbot is as somebody at Node said, so 2023, but it still comes to mind as one of the first things to think about in a let's say first stab at it. But more complex applications will come around soon and will be there, like you said, code generation. There could be something as well that is really beneficial. Looking at history, looking at maybe something that has been conversational. Imagine like this teleprompter app. You and I, we talk about an idea we have about something we wanna develop, but then we didn't transcribe our conversation, but we maybe forgot about it, and then this teleprompter app prompts it again and says, "Hey, you talked about this cool idea," and then maybe it spins it for us. So yeah.
Yeah. And my question to you is, what have you seen based on all these interactions with people? I'm sure you're talking to many, many people as trends in the space recently.
Yeah, lots of people, lots of conversations. So more or less these conversations here are back end driven. So it's lots about GraphRAG really. So that's the top content everybody wants to. Like I said, everybody wants to put their unstructured or semi-structured or structured and unstructured data in some kind of AI system and do something with it. And then the trends follow along. So that's why I mentioned agentic AI. I think that's currently where I see a lot of conversations. People talk about this a lot, and put something in and outsource almost like things you would have to think about yourself, or you were to do them into a AI driven system, and then gives you offloads lots of your work.
Fair. Okay, that matches pretty much to what I've seen. I think the space is gonna continue evolving pretty
Yeah,
rapidly in the next
exactly.
year. And I'm super excited to see all these GraphRags come to play. I've seen another 5 projects in the last week. I think like when we started, this didn't have a name, and it was just like a concept.
Yeah.
So I think like it's super exciting to be able to kind of participate and to do these things, and especially do them if we can, at that level and that scale that is actually production systems, and we change this dynamic of like snowflakes and redshifts of the world towards something more exciting and evolving. It's like I think it would be a good contribution if we could.
Yeah, definitely. So that's what I was surprised at the beginning, or what really thinking is unique about your approach is the dynamic part of it. So you still, even with most of these agentic AI systems, you set something up and it is relatively static. At least that's what it feels to me to be the case. And then when but things are evolving so fast and things are moving a lot. And then if you have something that can change and is adaptable to certain different kinds of requirements, so you could have your data in, but then one user wants actually code generation because they develop something, and then that helps them do it. But another user might have some completely different questions, and that it's still in some cases it might need a complete refactor of the whole data store, because you have different questions that ask different things of.
Oh, I lost the audio. Is that just me or? Yeah, I can't hear anything. No, sorry, maybe it's on my side. Should I try and rejoin or? Yeah, Alex, it seems others can't hear either. I'm sure he's going to be back soon. In the meantime, how about the commercial break? We can talk about the sponsor of this today's podcast. I'm joking. I don't know. Like, I'm just trying to. So, do you guys have any questions I could answer until he fixes his audio? So you guys are not stuck here. Okay, since I'm fine, yeah, I think I see this personal knowledge graphs question. Maybe I can answer that in the meantime. So we created this concept of a user graphs where you can actually. Uh, I've hosted the podcast now, so I'm the captain. Welcome. Yeah, the personal knowledge graphs. We create the concept of the user, so you can store for a particular user. You can create little graphs or subgraphs that just have their information, and then for particular use cases, you could also do that to an organization entity level. So you would avoid having these types of issues with the graphs that effectively are too broad and contain maybe some personal data you would not want to share with others in the system. Any archive articles I would recommend? Yes, many. I think there is a list on our documentation. I'll double check that. If you go to Cogni and then to Cogni's documentation page, you should see a list of articles. If not, I'll make sure to add that page back again after the call. But we had a list of around 20, 30 articles that inspired us in the past. Any other questions, or hopefully Alex comes back soon? So yeah, I think like koala paper, and then I mean to name a few, there was a recently one about generating graphs for and SQL with graphs that was I think pretty popular in the enterprise settings. So yeah, I think yeah. Are you back,
I
Alex?
think I'm back. My internet connection dropped.
No worries.
Sorry.
I took the lead just to.
Okay, great. Yeah, thank you very much. Sorry for that, everybody. Sorry for dropping off all of a sudden. It was really weird. I could still hear you, and then I couldn't say anything anymore, and then I don't know what's happened. Yeah.
Yeah, this happens sometimes.
It does happen. Yeah.
Yeah, so it's like I think yeah. Would you like to go through these questions? How much time do we have? Like I don't know what's
Yeah,
your
we have a couple more questions. I don't know. Did you discuss anything interesting? I see. Just let me quickly follow up on the wallet concepts from Dawn. Yeah, I think you probably talked about this. Alejandro says, I understand that there are certain parallels in cognitive neuroscience. Have researchers evaluated the impact of forgetting on learning, and how could this be effectively implemented if useful? Yeah, I think that is an interesting idea, because I was wondering about this myself as well. Is because you mentioned the forgetting part, and then yeah, I joked about internet never forgets. So and we all want to store as much data as possible. Everything needs to be saved. Everything needs to be put in some kind of database. Data lakes, everything goes in. But sometimes it might make sense to get rid of some of the older stuff, or some of the irrelevant stuff, and get rid of some ballast to streamline the important bits, or the relevant bits, or the things people are really interested in these
So
days.
there is so much research on this topic, on the forgetting, on how fast do we forget, what type of
Mhm.
information do we forget, how much emotional attachment to a certain type of information impacts it. This is also very connected to the trauma research. So, for example, if you see
Mhm.
the Vietnam War vets from the movies when they remember they're back in Saigon in 1968, that's actually happening for them. They loop back to that point in time, and their brain is kind of rotating in one old memory that they couldn't forget, and they can't really move forward. So, what I'm saying is the forgetting and the research there, it manifested itself already with like this time decay information, that like time decay metrics that you could add to the nodes, and there was some research done here. But there is many more strategies in the ways we remember and the ways we forget, and I think it's a very open field to kind of go through and research and bring back the learnings. I'm not too much of an expert here, but and definitely something that we need to check on our side a bit more. And I think in terms of the effective implementation, I think it's a quantification of the relationships in the graph, and then actually having for particular type of model have something actually work. And I think that's what I would say on this side. And I think in the context of summer internships, I'm seeing a question here. No,
yes.
we are not looking for those because we simply don't have the resources now to also manage interns. But like what I would encourage is you can always book a call with us if you want to, like some onboarding session, and our repo is open source, so any contributions are welcome. We're going to review them, merge them to the main branch, and you can definitely showcase the skills there. And then I think that's everything I've seen of the question.
Super. If people want to reach out, the website is probably the best place to check out. I'll post that in chat again, so you can find that, or like you said, go to the GitHub repo and put in your comments there.
What can I say? Thanks a lot for the chance to participate. If anyone's interested, give us a GitHub star if you like what we do. Try the library, open as many bug tickets as you can. I think I need to keep busy, so we are still new to this, and we want to have a really good system down the line. So more than welcome to the feedback. We have a Discord channel that's not too active right now, but we'll make change that. And join there, talk to us, ask questions. We're happy to add features and take the community feedback. We have a community roadmap too, so you can just you're going to be prioritized there, and you can see the progress on the things you open.
Cool. That's great. Thank you very much for joining us today, Vasilije, and for presenting this interesting topic, interesting approach, and interesting graph idea. So I would encourage you all to check it out and have a go at it. Let us know how you come around with it and what you do with it. So that definitely it's great to see. In terms of next things here on this channel, I'll be joined by Jesus again on the 3rd of December for the final Going Meta of this year, Going Meta episode 4 of season 2. So we will talk about semantics and knowledge graphs again, similar concept. So on the Tuesday, the 3rd of December. So if you're interested in this, then please join us and let's continue the conversation here. We are also looking at your feedback. So if you are a Neo4j developer and want to give us feedback on how you develop, how you code, how you learn new things, where you're from, and all your thought processes in going into developing with a graph database, then please let us know. It's a quick survey, shouldn't take too long of your time, and it would be helpful for us to prioritize on where we should be, what we should develop, and what you need and what you want from us. And in general, what to do next. Graph Academy is a great place to learn. Neo4j Aura Free is a great place to start with a graph database as a service for free. And then we have a community page. We also have a Discord server, so you can check that out as well. If you want to while you join Cogni's Discord server, you can also join the Neo4j Discord server and say hi and hang out with the community there. And with that, everybody, thank you very much for watching. I hope I see you on Tuesday. If you're in the States, have a happy Thanksgiving. Enjoy your long weekend. Don't buy too many things on Friday, or do, I know, as you like. Thank you very much again, Vasilije, for joining today and for the interesting conversation.